Hello everyone. So now we're going to start our solution for the static electricity worksheet, and we're going to start with this first question. All right, it says that P has a negative charge and Q repels P, which means that Q itself is going to have a negative charge. Now if Q has a negative charge and it attracts R, it means that R has a positive charge. So Q is negative, R is positive. Your answer is C. All right. Question number 2 says that a polythene rod repels an inflated balloon hanging from a nylon thread. What charges must the rod and the balloon carry? So they repel, which means that they have like or they carry like charges, because like charges repel each other. 3. Two similar balloons hang side by side on insulating threads. They are both rubbed with the same dry cloth and become charged. Which diagram shows how the balloons hang after charging? So if they were rubbed by the same dry cloth and they're the same balloons, this means that both of them will carry the same charges. So they would repel each other. All right, and the answer is 3. Question number 4. A plastic rod and a dry cloth are uncharged. The rod is now rubbed with the cloth and they both become charged. The rod becomes negatively charged because some charged particles move from the cloth to the rod. Now listen to me. The charged particles are electrons, so it's either A or C. It becomes negatively charged. So we want the charge on the cloth. So the electrons will move from the rod to where the rod becomes negatively charged. So the electrons would move from the cloth to the rod. So the cloth becomes positively charged. Another easy way to know this is that when rubbing, the end substances will carry different charges. So the rod or the objects will carry different charges. So the rod is negative. This means that the cloth is positive. Question number 5. What is an electric field? It's a region in which an electric charge experiences a force, and that is very clear. Question number 5. Going to question number 6. A polythene rod is rubbed with a cloth. Again, the rod becomes positive. Directly means that because the movement of charged particles. So if the rod is positive, the charged particles are electrons, and the electrons would move from the rod to the cloth. Okay, the electrons would move from the rod to the cloth. Because right now the rod is here. If electrons moved to the cloth, the cloth would become negative. The rod would become positive because the rod has less electrons and the cloth has more electrons. Question number 7. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What happened to the rod? If it became positively charged, it means that it lost electrons. Electric field, 2 parallel plates. It's D because it goes from the positive to the negative. Question number 9. A student holds a rod in his hand. He rubs the rod with a cloth. The rod gains a positive charge. Again, rubbing happens with insulators, so it's plastic. Transfer of charge, negative charge from rod to cloth. Okay, that's why the rod becomes positive. And I think you got used to it. The questions, I think, are the same. So in this question, what happens to the charges on the neutral sphere as the positively charged sphere is brought close? So the negative charges would accumulate here, all right, because opposite charges attract each other. The positive charges, they don't move, they stay in place. So the answer is D. Okay, question number 11. Electric field on point charges points away from positive, so the answer is A. Okay, 12. I think you read the question. Plastic rod is rubbed with a cloth, becomes positively charged. After charging the rod, it held close to suspended table tennis ball. The table tennis ball is covered with metal paint and is uncharged. So what would happen is the negative charges would accumulate here because they're attracted to the positive charge of the rod. So describe what happens to the charges in the metal paint. The negative charges will move closer to the positively charged plate. Okay? The positive charges don't move. Okay? When they say describe, they just want you to say what happens to the charges. They don't want you to explain by saying that unlike charges attract each other. It's just a description of what happens. Okay? All right, it's a 1 mark question, so you can neglect this last part. Okay, we can just, just go here. The negative charges will move closer to the positively charged plate. That's it, 1 mark. If it's 2 marks, you would have added that. Now the ball is attracted towards the charged rod. Explain why this happens given that the ball is uncharged. Explain. It's a 2 marks question. Okay, then what you would say is because opposite charges attract, the negative charges in the ball attract the positive charges in the plate, or in the rod. All right, state the unit. So the unit is coulombs, capital C. State what is meant by the direction of the electric field. This is the direction of the force acting on a positive charge. Okay, again, to draw this in the syllabus, you don't need to draw end effects, so you just draw straight lines. Okay, with an arrow, another straight line, with an arrow, another straight line, with an arrow, another straight line, with an arrow. Okay, and the arrows goes from positive to negative, and that's it. All right. Now, in this question, it says that there is an oil droplet which is negatively charged. So I'm going to assume that this is positive from the last question and this is negative. All right, state in terms, or suggest. Suggest means just give your opinion according to what's given in terms of forces, why the oil drop does not move up or down. Because the force of attraction, which acts upwards, is equal to the force of gravity, which acts downwards. All right, people, just give me a second.
10.
All right, it says then, without losing any of its charges, the oil drop begins to evaporate. State and explain what happens to the oil drop. Statement will be it will move upwards. Explanation is because the weight decreases. The weight is the force of gravity. It decreases. All right, so now the resultant force is not zero, so it will move upwards because right now the force of attraction is greater than the weight. Okay, simple question here. Draw the induced charges. If I place this, the ball is neutral, but the negative charges are going to be towards the positive charges, and this region would have a net positive charge. In this question, it's about calculating the average current, and the equation that we're going to use is that current is equal to charge over time, and the charge is equal to 2.8 times 10 to the power of negative 8 divided by the time, which is 0.05 seconds. Okay, just use your calculators to get this answer. In question number 15, it says describe. Remember this command term describe here means you don't need to give any reasons, okay? Just describe what happens. Describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. You would say negative charges will flow towards the plastic sheet. All right, that's it. That's your description. Draw on figure 10.1 how the charges are now arranged in the metal plate. So in the metal plate, the top part would be negatively charged. The bottom part would be positively charged. Just make sure that you draw the same number of negative and positive charges. State and explain if this arrangement of charge helps to keep the plastic sheet in place. Remember your statement first. Yes, it helps. All right, that's 1 mark here. Your explanation, because opposite charges attract. Good. All right, we're almost there. So shows 2 uncharged conducting spheres suspended on insulated threads. The spheres are now both given positive charges. Draw possible positions of each sphere. Both positive charges means that the 2 spheres would repel each other. Okay, they would repel because like charges repel. Explain the positions you have drawn. Now explanation is just what I said. Like charges repel. 1 mark for the drawing, 1 mark for your explanation. Again, shows a small black circle that represents a positive charge. Draw the pattern and direction of electric field. So the electric field would be outwards, like this, like that, like this, like that, like this, like that, like this. Finally, last question. Okay, calculate the current. Again, same idea. Current equals to charge over time. Now the charge is in coulombs. Remember that the time needs to be in seconds. So you got to multiply the 5 times to 60. So let me just use my calculator to give you this answer. Okay, this would give me 0.023, and remember the unit, it's in amps. All right, people, thank you very much, and I hope that this was helpful.